All right, hello everyone. So this is our semester one midterm study guide video. In this video, I'm going to give you some tips, just kind of, tell you what to watch out for, for the midterm, and just how, I need you to take this test. So the midterm, it's going to be about a half an hour, hour and a half, excuse me, and the majority of the questions are going to be unit conversions. Okay, so just make sure you know how to do unit conversions out of anything. Um, for parts like for the engineering design process, that would just be, some type of passage. And then I'll tell you to read that passage, to answer questions from the passage. Same thing for evidence-based reading, and annotation, bullying, cyberbullying. Very confident everybody will do well on area, perimeter, and volume. So I'm going to definitely give you a lot more questions than three. Um, and then make sure you prepare for the two T-chart conversion problems, which are the word problems. Those will be on a test. Okay, so let's go through this midterm and let's go through some things. Okay, so John needs to create a boat from a 20-gram ball of clay. His boat must float and hold 10 marbles. He will follow the he will follow an engineering design step to help him through this. Match the EDP steps to John's activities. Okay, so with this problem, you have to make sure you read the text here. Okay, and it's really all of it is in the words. So do not just try to guess it. Definitely read this part. And your co-teacher after this video will definitely give you the answers and explain to you, how, what are the correct answers. Okay. For this part, you just have to really read it. I'm going to really set you up for success, but you have to read this part in order for you to answer these questions. These questions here are not going to be too difficult. They're not going to be too hard, but you have to read the passage, and it's going to be pretty long. Okay, so please, please, please read the passage. And while you're reading the passage, make sure you're underlining important things so you can know what to look out for. Okay, so for example, it seems obvious in order to solve a problem. Okay, so what are we solving? We're solving some type of problem. We must first identify what the problem is. So that's that word problem again. Sometimes this is not straightforward. For example, what appears to be a problem. Okay, so you're looking for clues, you're looking for key ideas, and then once you summarize up all those key ideas, make a conclusion, all right, and then answer the questions, all right. Area, perimeter, volume, I'm going to give you the equations for this, so just make sure you remember the equations. So remember the equation for area, and remember this is the area of a rectangle. Okay, I didn't specify that earlier, but we're talking about the area, volume, and perimeter of a quadrilateral or four-sided object. So the area for a rectangle is just length times width of one side. The volume of it is the length times width times height. The perimeter is going to be 2 times L plus W. L plus W, length plus width times 2. Okay, so if you remember these three equations, I could throw 10 of these area, perimeter, volume questions at you. You should be able to figure that out. And then also remember, if I have a cube, all right, how do we identify the length, width, and the height? Okay, so the height is always going to be how tall it is. So that's going to be this side here. The width is going to be how wide it is, and that's going to be this side here. And how long it is going to be the length, which is right here. Okay, and that's for any 3D rectangle that I draw. Okay, so ask yourself, where's the height, where's the width, and where's the length? Go ahead. So the height is going to be how tall it is. The width is going to be how wide it is. And the length is going to be how long it is. All right, so that's for area, perimeter, and volume. Okay, so 2T chart unit conversion PSDA. Okay, so we have a robot that can hold 300 milliliters of water in a reservoir. Based on the information above, how many robots would you need to hold 3 deciliters of water? All right, so we know that a robot can hold 3,000 milliliters of water in a reservoir. A reservoir is just a cup, okay? Based on information, how many robots can hold 3 deciliters of water? Okay, so we know that one robot can hold 3,000 milliliters. We want to know how many robots can hold 3 deciliters. And the key idea with this question are the units. If you have a word problem and they give you a unit, millimeter, deciliter, gram, kilometer, if they give you more than one unit and those units do not match, that's usually a clue that you have to do some type of conversion. Ask yourself, what are we converting to and from? So you should have postulated that you're converting from 3,000 milliliters to deciliters. Why? Because you're trying to figure out how many robots can hold 3 deciliters. And remember, this is very, very important, especially when we get to the end of the problem. Okay? So we have to convert from milliliters to deciliters. So that means that we need to know what are the conversion factors to get from milliliters to deciliters. We see our box here. It says that 1 deciliter equals 10 liters and 1,000 milliliters equals 1 liter. Now we have 2 conversions, so that means that conversion factors, so that means that we're going to have 2 T charts. Okay, so let's go ahead and convert it and see what we're going to do with this special 3 deciliter at the top here. So all you're doing is just matching, it's just a pattern, and you just take a number with it, okay? So if this is milliliters, I know that this has to be milliliters here because I want them to cross out diagonally. Okay, so what number here is next to milliliters? 1,000. So I'm going to put 1,000 here. And then whatever this 1,000 milliliters equals to goes at the top. What does 1,000 milliliters equal? 1,000 milliliters equals 1 liter. So I'll put 1 liter at the top. Now, before you go to the next T, you want to make sure that this conversion that you just did was correct. And the way that you know that is by the units crossing out diagonally. If the units are the same diagonally, then the conversion is correct. All right, I had to write that out just so you can hear that if the units cross out diagonally, then the conversion is correct. Okay. All right, so do they cross out diagonally? Yes, because they match. Okay, so now I have liters here. That means I have to have liters here because this rule. Now, ask yourself which number has liters next to it? 10 and 1. Now, we know that we already use 1 liter, right? We use that up here. Okay, you can't use the same number for another T chart. Okay, you already used it. So it has to be 10. Okay, and whatever this is equal to goes at the top. What is 10 liters equal to? 10 liters equal to 1 deciliter. Okay, and so how you know you did that right? Because the liters cross out. Okay, so now I want you to look at this little line here and this little line here. These lines are going to represent multiplication. So everything that is next to each other, you're going to multiply each other. And everything that's on top of each other, you're going to divide. But we have more than 2 numbers here. So that means we have to simplify it first before we do any type of division. So that's why we have to multiply first. So it's going to be 3,000 times 1, which is 3,000 deciliters. 1,000 times 10, 10,000 milliliters. 10,000, excuse me. All right. Now we have 3,000 deciliters divided by 10,000. 3,000 divided by 10,000 is definitely a decimal. 0.3 deciliters. So 1 robot can hold 0.3 deciliters. Now we want to figure out how many robots can hold 3 deciliters. Okay, so this is a piece, this is a whole. How many of these goes into 3 deciliters? So that's either addition, subtraction, multiplication, or division. We're not adding because they are not the same quantity. We're not trying to figure out what they are, the sum. We're not trying to figure out the difference, so it can't be adding or subtracting. And we're not trying to figure out the product. We're trying to figure out how many of these fit into this. And so that means you have to divide 0.3 by 3 deciliters. And then your answer should be 10 robots. All right. So this problem, you only get good at this problem just by practicing it and make sure you understand every step. Okay. Don't just memorize. If you memorize, it won't work. Okay. All right. So for this part of the test, it's just going to be another reading, and you're going to have to answer questions. I'm going to ask you to write summaries, so make sure you summarize and disregard those questions there. All right, so this problem is the same as the one before. Okay, I want you to go ahead and try that problem out on your own. Well, actually, I don't think this one is in your study guide, so don't worry about it. But this problem will be on your study guide. So on your test. So you can go ahead and just try it on a separate sheet of paper. Okay. All right, metric unit conversion. Just make sure you remember the ladder. So if I have base, which is meters, liters, and grams, to the right, which means I'm going to move my decimal to the right, or moving down, right and down are the same thing. Okay, so if I move down, I move to the right. If I move to the right, I move to the right, obviously. So to the right is going to be deci, centi, milli, micro, nano, pico. To the left, going up,